In today's lesson, we will be going over one of the most basic hand tools, the screwdriver. We will discuss what it is, what it should be used for, and how to use it safely and effectively. Following the presentation, there will be a short review quiz. A screwdriver is used to increase torque when driving screws into and out of a material. Torque is the measurement of how much a force acting on an object causes that object to rotate. In this case, the force is transferred from our hand to the screwdriver, causing the screw to rotate. Torque can be calculated by measuring the distance from the center axis of the rotating object, the screw, out to where the force is being applied, our hand. Then, multiplying this measurement by the amount of force exerted on the object, we can find our torque. A screwdriver has four basic components: the handle, the shank, the blade, and the tip. In this lesson, we will be focusing on the two most common types of screwdrivers, the Phillips head and the flathead. Although there are many types of screwdrivers which can be distinguished by their tip and what type of screw that they drive. For every screwdriver type, there's also a size that distinguishes it amongst the sizes of screws being used. A regular or flathead screwdriver has a flat blade that fits into the single slot of traditional screws. This is the oldest and most common screwdriver in the world. A Phillips head screwdriver, on the other hand, has a 4-star point at the tip, which fits into the corresponding screw's equivalent shallow, cross-shaped depression. This allows for more torque to be applied in comparison to a flathead screwdriver. Excess torque on a flathead screwdriver can cause damage to the screw, the workpiece, and the screwdriver tip. By expanding the design of the tip of the screwdriver in both directions, we can apply more force when turning without causing as much damage. Damage can also be applied when you use too small of a tip or too large of a tip on the wrong size screw. Never place it in your pocket, as this can cause bodily harm if you're not careful. Also, you should never use a screwdriver while performing electrical work, unless the screwdriver and the operator are properly insulated and protected from the electricity. In this video, you will see how to safely and effectively remove a screw and drive it back in. Be sure to keep a firm hold on the screwdriver as you apply pressure to and rotate the device. Failure to do so can result in slippage and damage to the work surface, as well as the screw and/or screwdriver. Taking your time as you drive the screw in can also keep you from damaging your workpiece or yourself. Are there any questions over the materials we have covered? On a blank sheet of paper, please number from 1 to 8. Questions 1 through 4 are for you to label the components of a screwdriver, and questions 4 through 8 are covering the rest of the material discussed in class. I would like for you to answer the questions alone, and when everyone is finished, we will go over the answers as a class. Then, everyone will turn in their papers as they are graded. Are there any questions? Let's go over the answers. Number 1 is a tip. 2 is the shank. 3 is the blade. 4 is the handle. 5 is the Phillips head and the regular or flathead screwdrivers. 6 may be any two of the following: prying, wedging, and punching. Number 7 is torque, and number 8 is false. This will conclude the lesson for the day. Thank you.